How do vortex tube coolers work? And when you first come across vortex tubes, they seem like magic. We have a device that has no moving parts, no power source other than the compressed air that goes into it, and can produce temperatures down to -40 degrees C from an ambient air temperature. All this with no refrigerant chemicals being used. It sounds a bit like magic, but it's actually basic physics, although the physics is actually quite complicated and in some cases debated. We're not 100% sure how it all works, but they do, and I'll attempt to explain what we do know about how vortex tubes work in this video. So in a vortex tube, compressed air, as the name suggests, is forced to move in a rapidly rotating vortex. Now this rotation of this vortex can be very, very fast, up to 1,000,000 revs per minute in some cases. So it's moving very, very fast around the chamber inside the vortex tube. Now at the hot end, a special valve allows some of the air to exit. Typically about 30% of the flow is allowed to exit. This valve is shaped so that only the outer edges of the spinning vortex escape, and the rest of the air is actually forced back down through the vortex into itself and into the tube through the center of that vortex. So what we've set up here is a very rapidly spinning vortex flowing up on the outer parts of the chamber, and then it's reverberating round, rotating in the opposite direction through the center of the vortex. So due to the motion of these two airflows, we have a lot of motion and a lot of friction between these two air streams. And what we're effectively doing here is setting up a heat exchanger. The outer part of the vortex heats up, takes heat from the inner part, the reverberated air stream. As the valve at the hot end is shaped so that only the hot air escapes, and as the cold end only allows the centrally located cold air to escape, hey presto, we separate the air into a cold air coming out one end and hot air coming out of the other, all with no refrigerants, no other external power source. Now, no actual heat is generated in the vortex tube. The heating of the hot air exhaust matches the cooling of the cold air. No energy is being added to the system, added to the compressed air. It's purely separating it into a cold and hot air stream without adding any energy to the system. The ratio of cold to hot air can be adjusted just by changing the valves. Normally the optimal cooling can be achieved by having the cold fraction around 70%, so 70% of the air is cooled down and 30% is heated. Now obviously the 30% of hot air has a greater delta T, a greater temperature rise than 70% of cool, so the hot end can get quite hot. So for a 40-degree cold end temperature drop with 70-degree cold fraction, we would expect to see a corresponding 93-degree temperature rise on the hot end. So we would get hot air of around 113 degrees C and cold air of around -20 degrees C if we're starting off with compressed air to a 20-degree ambient temperature. So there's many applications where these seemingly magical devices are very, very useful in factories around the world.